Okay, we're going to be looking in this screencast at transformations. And what we're doing here is we're looking at, we're taking graphs and we're transforming them. We're looking at the different ways that can happen, and we're looking at the different, and the things that you can do to functions, you know, add, subtract, multiply, and where, and what effect that has on a graph. Okay, so we're going to start off by having a look at, say, a graph of our old favourite x squared, just our trusty old parabola, and there he is there. Now that's just y equals x squared. There's the function there, f of x equals x squared. Now we're going to affect a translation on this, and this is how we're going to do it. We're just going to, if I just went into that function there and said, right, let's just add 1 on the end of that, and look what happens. I just bumped up 1. Right, well, that's fine. That sort of makes sense because I'm just adding 1 to the function, so everything moves up 1. Right, everything moves. Its y coordinate increases by 1. Right, so what if we subtracted 1 here? Subtract 1. Oh yeah, that goes down 1. That's a translation, and that's a fairly straightforward one. I'm going to go through these transformations in order of complexity. Right, so we're starting off with translations, the easiest. All right, so let's go back into this function and get rid of the thing on the end. But now let's have a look at what happens if we. What about if we do this? What about if we add 1 in here? What's the effect of that? Oh, what happened there? So it didn't move up or down, it just moved left 1, but I added 1, it went left 1. That's weird. So what happens if we go in and subtract 1 in there? Don't tell me it's going to go right, it goes right. Okay, so translations are there as such. They're the 4 translations, up, down, left, right. And the left, right, the horizontal translations there, it's what we might call counterintuitive, in that the negative in here moves right 1. All right, let's have a look at a double translation where we go, let's say it's squared, but then we go add 2. And what's going to happen here? It's got -1 inside. What does that mean? That means left or right means it's counterintuitive. So go right 1 and the +2. That's as we'd expect. So up 2, and there we go. So from its starting position of x squared, it's gone right 1 because of the -1 here, and up 2 because of the +2. Righto. So that's nice. That's a translation. Let's have a look now at what happens with our second transformation, which is I'm going to go to a new page. Let's go to a new page, new sketch, and put a new coordinate system down. Pop up another little text box and call it. Let's say this is 2, and this is a reflection. Right, this is 2 of 3 reflections. All right, what sort of function should we look at here? Well, I think we should go and have a look at maybe maybe we look at x squared again. X squared. All right, there it is there. Now, what happens if we put just a little negative out the front there? So what we're going to do is we're going to find minus of that function. All right, so that's minus x squared. That's in brackets. Okay. Oh, look what happened there. So a negative out the front. What happened there? It reflected in this axis here, this x-axis here. So a minus. So that makes sense too, because what we're doing is we're taking everything that we had and we're just making it negative. So if y coordinate of 6 became -6. If we did that, everything like this little reflection in the x-axis. Right, let's have a look. I'll get rid of that one. Perhaps we'll go in here and edit the function and just delete the whole thing. And what we might look at now is just the straight line x. That's y equals x, you see? Now what happens in here if we, let's edit that function and just put a minus in front of that. And there we go. It reflected in the x-axis. So there's another example of that. Now looking for an example here of, let's say I'm thinking of it. So let's go back in here and find what happens when we not just minus out the front, but we take a function, let's say x plus 6. Go back to the parabolas, we like those, and x was 6 squared. Where's that going? Do a little prediction. Right, I went left 6, didn't it? Even though we thought it might have gone right 6. Okay, what happens if we go in and, right, if we put a minus out the front of that, right, put a minus right out the front of that, what's going to happen? Reflects in x. But if we put that minus not there, but in front of the x, what happens? All right, remember where it was? It was over here. Okay, so if I look at the, I'll plot another function, plot a new function. What was it? It was x plus 6 all squared. That's what we started with. And then I put the minus in the x, and it flipped over there, so it reflected in the y-axis. Right, that's wonderful. Now, what I want you to know is that I've made some notes here. And we'll go to these at the end, and I'll give you a chance to copy them out. So what we've covered so far are 1 and 2. We've covered the translations, the up, down, the left, right, and now the reflections. Just had a look at with the minus out the front in the x-axis. And when that minus is in the function itself, it is reflected in the y-axis. Now we're going to have a look at these, what we call stretches and compressions. So let's go back over here, and what we're going to do is go in. I think I've already made a few. No, where is it? Yep, there it is there. So now we're going to look at what happens when you take a function. I'll get rid of that plus 1 in there for the moment, because to simplify this up a bit. So what we've got here is I've set up, and this is my function, right? And I've got these values of A and B here, which I'm just going to move down a little bit, give me room for my heading, which is going in a little text box here, right? Because this is 3 stretches and compressions. That's what they're called, right? Now this is our stretches and compressions. This is our third translation. Right, now this is our function. Have a look at that. I want to make that a bit bigger as well, because that's important. Right, this is saying the function of x is equal to a, which is just in there, a times bx squared. So what I want to do is I want to look at the effect, because what we've looked at so far, if you remember, the first one, translation, is just adding either inside or outside. Second one, multiplying by minus 1 effectively, minus the function or function of minus 8x. Now I want to look at, all right, what's happening in here. All right, what about if we multiply a function? So what I multiply a function by, let's say an a in this case. Now b is set at 1 and a is set at 1. So currently this is just x squared, and you can see that's our x squared there. I'm going to put a little trace on this. I've got a trace on there. Good. What happens as a increases? So we get, this value of a becomes more than 1, right? And we start to look at the effect of that. And there it goes. And what we call that, and you can see it's how it's changing. And you see a is now just passing 2, and that's called a stretch. And what it is a vertical stretch. And you can see what's happening is we say that that's being stretched and pulled away from the x-axis for these values of a that are greater than 1. All right, now if I just erase those traces and I back it down again, all right, now I'm bringing the values of a back down. So currently you can see at top left here it's 2, and it's coming back down. And it's what we're calling, what we'd say about this is that it's compressing now. It's compressing towards the x-axis. I'm going to stop it at 1. I'm going to erase the traces back to where it started. Now we look at values of a less than 1, and what we say there is that is a vertical compression, or that the graph is being pulled back in the direction towards the x-axis. So greater than 1 away from the x-axis vertically, less than 1, this value of a towards the x-axis in a vertical direction. All right, while we're at it, why don't we flip this right across? Look how low it gets here. All right, that's a compress in. All right, and we get down here, and look what happens. Let's go right back to minus 1, and we'll get a really nice effect here. And you'll see that reflection, because at minus 1, we're just looking at minus x squared. So x squared's up here, and minus x squared down here. So a nice little reflection. in the x-axis. Righto, so let's just get rid of those. Actually, what I need to do is I need to get back in and change this value. Edit parameter, we'll get that back up to 1. There it is there, and we'll just erase the traces again, and then we're back to where we started. Right. So for values of A, and this is in the notes here, you'll see it. With this value, we call it in the notes P, but it's what we just had as A. And in fact, it would make it easier, wouldn't it, if I called this here. If I gave that the name, the label of P rather than A. That would be much more helpful. Now this value of B in my notes, well, it's Q, so let's call that Q, and then we know what's going on. Right, so as values are in, go back to the notes, as P stretches vertically with the value of P stretches the function vertically with scale factor P. So if P is greater than 1, it stretches away from the x-axis. If P is between 0 and 1, it compresses towards the x-axis, and we know that if P is less than 0, then it's a reflection. Okay, let's have a look at the effect now of what happens here when we bring that multiple in and it comes inside the function. So we're multiplying x by it before we apply the function, if you like. So let's go and have a look at that. So what we're going to do now is keep P at 1 but change Q. All right, so in this here, we'll have a look at this value of Q. Now let's go, and what I'm going to do here actually might make it a little more effective to change this as I had it before and just put a +1 in here. So it just shifts it to the left. Okay, just to the left one. Now let's have a look at what happens when Q moves. Let's just shift Q around, and there we go. Now Q is going up at the moment. It's getting towards 2, and look at that. And what we say there is, what we call that is a horizontal. In this case, it's a compression. It's towards, as Q gets larger, it's a compression towards the y-axis. You see how my function is being pulled into the y-axis, and the scale factor is 1 over Q. 1 over Q, 1/3. It's pulling it in. Okay, let's bring it back down again and see what happens when. So that's for Q greater than 1. When this value of Q in here is less than 1 but greater than 0, let's have a little look at what happens. So I'll bring it back down to 1, and we're going to be back to where we started any moment now. Right, I'll get rid of those traces. We're back to where we started. Q's at 1. What happens when Q gets less than 1? What we say there is that that's a stretch, a horizontal stretch, where the function, the graph, is being pulled away from the y-axis, and that's when Q is between 0 and 1. Have a look at this. Righto. Now what happens when Q is equal to -1? We're going to see this lovely effect here, I think, aren't we? There's that reflection in the y-axis. It's gone from here to here, a nice little reflection in y. So all these notes are summarized right here. If I just, they're all the notes there. So if you want to pause the screen there, get these notes down, because they summarize those 3 transformations that we've just discussed. Translations 1, reflections 2, and then the stretches and compressions. I'll see you in class on Monday, and we'll have a look at the final exercise in Chapter 1 on functions. Okay, cheers.